Continuing with our section B, machine learning concepts, we are going to review these match the following columns. The first one is Manhattan distance. It corresponds to sum of absolute differences, which is k equal to 1 distance metric. Right, and the it measures how far two points are from each other when we only can move horizontally and vertically, similar to navigating a grid-like city such as Manhattan. Right. Next, Euclidean distance. This corresponds to the straight line distance, that is the k equal to 2 metric, and this is the most common measure that represents the shortest path between 2 points in continuous space. Moving on to the correlation measures, the Pearson coefficient is paired with the covariance of x comma y divided by the standard deviation of x into standard deviation of y. This quantifies linear correlation between the two variables by standardizing the covariance. The Spearman coefficient, on the other hand, matches the correlation based on the ranks. Rather than using their raw values, it assesses how the relationship between two variables can be described by a monotonic function of their ranks. Let's see about the regularization ones. The L1 regularization corresponds to the shrink to the squares to zero. We want to shrink the coefficient, some coefficients to zero. This property makes use L1. This makes L1 useful for feature selection. Similarly, L2 regularization matches with the shrink all the coefficients proportionally. It does not force coefficients to zero, but reduces their magnitude, helping control model complexity. Next, we consider ensemble learning, right? So, bagging basically pairs with bootstrapped aggregation of trees. So, it reduces variances by training multiple models on different bootstrap samples, averaging their predictions. Boosting aligns with sequentially focuses on misclassified samples. Each new model attempts to correct the errors of the previous one, gradually improving their performance. Now let's also see about the regression. The ridge regression matches with uses penalty lambda into sigma of beta. It's not showing correctly, but I believe that it is the summation of the summation of lambda, uh, sorry, the lambda into the summation of beta squared. This is the coefficient square. This is the L2 penalty that distributes shrinkages across all the coefficients. And similarly, lasso regression corresponds to the lambda into the summation of absolute value of beta, that is the summation of all the coefficients. This is L1 penalty, encouraging the sparsity by driving some coefficients to zero. Thank you.